Welcome everyone. Welcome to this session, ArcGIS Maps SDKs for Game Engines, an introduction. Welcome to people joining us online and welcome to people in the room here. We'll go through a set of slides. We've got a demo as well. We've got some customer examples, and then we'll have a Q&A at the end. If you're joining us online, you're able to ask questions via the Pigeonhole facility. So please start asking those questions as we go through the session. We'll assemble those and ask those at the end, and then obviously we can take questions in the room as well. My name is Mike Branscombe, a product manager working on our Game Engine SDKs. I'm joined here on stage by Zach Allen and Mason Gore, both engineers working on our Game Engine SDKs. Zach specializes particularly in virtual tabletop scenarios, and Mason's been looking at our samples in our public GitHub repos, particularly looking at extended reality or AR, MR, VR scenarios as well. Agenda for the session then, we'll take a look at an overview of the SDKs. We'll look at immersive apps and what immersive apps are. Then we'll take a look at some customer examples, how you get started with the SDKs, the capabilities, and then what's new, and a brief glimpse of the roadmap. So the Game Engine Maps SDKs then enable you to bring GIS data into game engines and build a range of immersive 3D and extended reality application experiences with game engine technology. The game engines themselves provide photorealistic rendering, lifelike special effects, animation, physics, and then our Maps SDKs are plugins to the game engines, and we support the industry-leading game engines, Unity and Unreal Engine. So the plugins then provide geospatial canvas in either global coordinate system or local coordinate systems inside the game engine, so you can work with your precise real-world GIS data. As client SDKs to the ArcGIS system, they support a range of high-performance, optimized data sources. And they're free to download, free to develop with, and free to deploy applications. So from an ArcGIS perspective then, to represent that visually, you'll bring services and content from ArcGIS into game engines, Unity, Unreal Engine. You'll use our Maps SDKs for game engines, and you can use those to build a range of desktop applications, 3D desktop applications, mobile applications, but also specifically immersive extended reality experiences as well. Of course, the applications that you build will bring in business data from other enterprise systems that you have, and you'll integrate with other plugins as well to bring in other capabilities into the applications that you build. So to put the Game Engine SDKs into context with our other ArcGIS technology then, we have several patterns that we talk about when developing with ArcGIS. There is automating ArcGIS, and for that we have the ArcGIS API for Python. There is extending ArcGIS, and we have an SDK for ArcGIS Pro and an SDK for ArcGIS Enterprise. And then there's a pattern about creating applications. So we have a series of ArcGIS Maps SDKs. They target game engines, native applications, web applications, and then we also have application builders for a low-code, no-code experience targeting the web. And also we support a range of open source APIs as well, including Leaflet, for example. But specifically, we're focusing on the Game Engine SDKs today. But this is to put them into context. So essentially, it's another client technology that you can use to build applications when working with ArcGIS content. So what about immersive apps? And that's a term that we'll use a lot throughout this session. Well, when we think about immersive apps, there's really a spectrum of immersion. So looking at the line here from the real world, physical reality on the left-hand side, moving to the right-hand side, we go through increasing levels of immersion. So augmented reality, about overlaying information onto the real world around you. Mixed reality, so the merging of digital information and the real world. And then virtual reality, a full immersion experience in the digital world. And then collectively, we refer to these different experiences as extended reality, or XR. So what are immersive apps then? We think about immersive apps as apps where the user feels fully immersed in that experience. So they're applications using technology and techniques to fully immerse the user so much that they begin to feel like it's real life. Fundamental to these experiences is a complete digital replica of the real world, so a digital twin, if you like. And then based on authoritative geospecific GIS data and content. These immersive experiences need to look like the real world, so taking advantage of photorealistic rendering in the game engine, but they should also behave like the real world as well, so animation with lifelike behavior. And then integrating a time component for past, present, or real time and future. So why build immersive apps at all? Well, immersive apps increase the level of engagement that users have with the content that they're seeing or the workflow that they're experiencing. That leads to enhanced retention of knowledge or enhanced retention of the skills that they're learning, greater understanding of the context that they're working in, and ultimately improved decision-making. So it's about the use of game engines to build the next generation of 3D geospatial apps to build a truly immersive experience. What about why game engines then? So it's worthwhile considering the opportunities that game engines provide in building applications. Developers choose game engines to build custom applications because they want to build specifically these 3D immersive experiences. Game engines specifically enable them to target augmented reality, mixed reality, and virtual reality applications. But not just those environments, also desktop applications and mobile applications as well. So cross-hardware development, including a range of head-mounted devices or headsets that are specifically tailored for XR experiences. And then developers choose game engines because of the photorealistic rendering, that lifelike animation, and special effects. There's also something that's often overlooked is the existing ecosystem of the game engines themselves. So both Unity and Unreal Engine have asset stores or marketplaces where you can bring in additional assets and plugins to build your applications. So for example, if you need a weather system, you can go out to the asset store or the marketplace, and there's a range of weather systems are available that you can bring into your application. And these are built by game engine developers and designers around the world. Also, if you're building an application and you don't have the skills necessarily, then it also means there's a pool of existing talent in the game engine development world that you can lean on to hire or contract. So some examples then. This example, the first one, is Skyview Bonn. So it's a traffic simulation of existing everyday travel in addition, with the addition of participants that are traveling to a conference in the city of Bonn in Germany. It was created through a collaboration between Esri Germany and Sprintines, who specialize in software development for digital transformation and optimization in several industries, including automotive, logistics, and urban planning. The initial simulation involves running from 1 hour between 7:30 and 8:30 a.m. It involved calculating around 3,000 trips, so that combination of existing everyday commuting combined with people traveling specifically to the conference. They used AB Street, it's an open source transportation planning and traffic simulation software for creating cities that are friendlier for biking, walking, and public transit. A trip can be multimodal, so it can switch from car to pedestrian and back again, or even bicycle. In addition, the carbon dioxide emissions are calculated and displayed. So in that panel, in the top right-hand corner, we can see the type of travel, so the dots that we're seeing animated around the city and the trails that they leave, they're color-coded or symbolized based on the mode of travel, and that's what we're seeing indicated in that panel in the top right. And then we're also seeing the carbon dioxide emissions in kilograms per second. Some additional post-processing of the data was done in ArcGIS Pro, and then the data was exported to a mobile geodatabase. Each trip is simulated and animated in the game engine itself, so taking advantage of the game engine for that animation. And then in the scene, we initially saw a 3D object scene layer coming from a scene layer package, and then that switched to this integrated mesh scene layer that we see here. That was created by partner AeroWest, and that's a 3-centimeter resolution integrated mesh. And then underneath those is the ArcGIS Online elevation layer and base maps as well. We also saw 3D pushpins that are coming from a feature service and then being rendered with assets inside the game engine. And I think finally, we also saw 3D text indicating the compass directions for the pilot flying their helicopter around there. The next example is from a software company based in the UK called Masters of Pi. They specialize in extended reality or XR collaboration solutions for defense and enterprise. This demo showcases what they call their digital bird table. So it's essentially a mixed reality tactical sandbox where users participate around a virtual tabletop and they enjoy a feast of information. Yeah, they're using this XR experience to enable a fully decentralized headquarters where people's physical location isn't a barrier to them collaborating and participating in the scenario. It minimizes a single point of failure as well in the case of a wildfire or power outage or flooding. Initially, we saw several UI panels for controlling the environment, and then we saw the avatars of other participants. They have several different modes here, so a flat 2D map on the tabletop with base maps from ArcGIS and other layer types as well. They've got custom military symbology in here. They're using real-time information. And then they have a series of specialized layers as well for showing orders and operations. And then they, as you might expect, they have a 3D mode. So here we were looking at a visibility fan or a view shed and highlighting the ridgeline. And then we're switching to being able to actually interact with these features and move them around in a collaborative planning scenario. And then the third example that we've got here is voestalpine. So they're a leading steel processing and technology group headquartered in Linz in Austria. And they're building a digital twin of their industrial steel processing plant in Linz. It incorporates both 2D and 3D spatial data, but also temporal data as well. So they have a number of different data sources, including building information model or BIM, but also computer-aided design and computer-aided engineering models as well. They've got multiple different capabilities and multiple different experiences onto that data as well. They plan to provide multiple ways for users to visualize and interact with their digital twin, including 2D dashboards, virtual reality, and augmented reality. So here we're seeing the VR experience. We saw it on a desktop with a mouse and keyboard, but naturally, with the game engine, you can also use game pads for intuitive controls, and then moving to virtual reality with a headset. So more interactive, more immersive experience, actually being on site, being able to experience and interact with the plant in different locations. And then lastly, we'll see what they're building as a VR training app for drivers navigating around the facility, around the plant, to learn how to safely navigate the complex facility. So here we see that driving simulation. In this case, it's a forklift truck, but they have many different types of equipment that drivers need to learn to safely navigate around the processing plant. And they're able to detect issues such as vehicles trying to go under pieces of equipment that are maybe too low. And then they have a series of next steps. They're looking forward to continuing to build their application. All right, so now I'd like to hand over to Zach, who's going to give us a demonstration of how you get started with our SDKs.
Thanks, Mike. First, we're going to show getting started with a Unity project. Prior to this session, I created a fresh, clean project in Unity. I have that open here. As you can see, we don't have any assets in here. And to get started, we want to get our plugin installed. So recently, we have added our plugin to the Unity Asset Store. So it's available for download from our website, the developer website, or the Unity Asset Store. I'm logged in with my Unity login here. I can click Open in Unity, and we have our plugin ready to import. I already have it imported into this project, so we can go about adding a map to the project. You can open our map creator panel. This has all of our plugin features. Everything's grayed out because we don't have a map yet, so we'll start by creating a map. Now that map is a game object in our scene. And next we might want to add elevation or some base map layer, but we can see all of these are grayed out. That brings us to the next step, is getting an API key. So that brings us back to the developer website. So we can go to the API keys section of the developer dashboard, create an API key. You can copy that key and paste it right into the plugin. Now we can see a base map layer appearing, but our map is at 0, 0, so we're in the middle of the ocean, and we probably want something more interesting than that. So I think next we're going to bring in a piece of data. So this is a 3D object scene layer of buildings in New York City, part of the ArcGIS platform and ArcGIS Online. We can copy the link to that and add it as a new layer in our map through the plugin. So we'll select the data type for 3D object scene layer, copy our source URL, add a name, add it to our scene. Once it is in, we can zoom to it. And we can see on our map, we have buildings starting to load in. I will zoom in there. Actually, first we need to add a camera. So we go here, hit the Create Camera button, align it with our current view to get our correct coordinates. And now I can zoom in. We can see base map tiles loading, building objects loading, and elevation loading. We can now interact with the scene and start building our app. Next, I wanted to talk about plugins that we include with the sample and transition into talking about getting started with Unreal Engine. So for Unreal Engine, we can download the plugin from the developer website. And in our Unreal Engine project, we have a folder. Here we create a plugins folder, if there isn't one already. And we copy over our plugin and open our project. So I already have it opened for the sake of time. And we have a new scene here, but I wanted to show the scenes that we include. So if you go into the Content Explorer, and under our plugins, ArcGIS Maps SDK for Unreal Engine, samples, we have examples of global scenes, local scenes, tabletop scenes. These are good starts to the basics of our plugin. And now here we aren't seeing anything. We haven't put in an API key yet. We have a very similar interface in Unreal. Actually, I want it to be in the global scene right now. And so here we need our API key. We can go right back to the web browser. Copy our key that we created earlier. And now we can see all of our data loading in. You can see that this sample scene already has a couple layers. We have 3D buildings for San Francisco and population data for San Francisco, in addition to our elevation and base map data included with this scene. Yeah, getting started is very quick. Just create a project, add our plugin, and you can create a map in a new scene or open existing scenes to start adding your data and exploring with our plugin. Back to you, Mike.
All right, thank you very much, Zach. So that was a great demo of, to give you context of what it means to bring GIS data into the game engines. You also saw Zach using what we talk about as low-code, no-code tools inside the game engine IDEs. So the map creator or the modes panel UI that Zach was using to configure the map and the camera and layers, that's all part of a kind of a low-code, no-code experience that we're building inside the game engine just to make it easier for you to get started and minimize that amount of code you have to write up front. So Zach talked about the availability of our Maps SDK for Unity in the Unity Asset Store and how that makes that a really nice workflow to bring the plugin into the Unity IDE. In future, we do also plan to make the Maps SDK for Unreal Engine available in the Unreal Engine marketplace. We're just going through a vigorous or rigorous verification and certification process. So it's great to know as a developer that when I bring in assets from these stores, that I know I can safely use these assets because they've been through a good verification process. So we're just working through that with Epic Games now. All right, what about the capabilities of the SDK then? So the Game Engine SDK support a range of high-performance, optimized, cached layer types. So we'll start top-down with 3D content. They support building scene layers for BIM data, 3D object scene layers, and integrated mesh scene layers as well. So BIM data or building scene layer data typically comes from models that have been imported, like a Revit model that's been imported to ArcGIS and then shared as a building scene layer. 3D object scene layers typically represent buildings, for example. They could have been generated from extruded building footprints or other data, and often generated at the scale of cities or regions. And then integrated mesh scene layers are a continuous surface. So these typically represent ground, buildings, vegetation, elevation, and maybe the result of imagery captured by drones and processed with ArcGIS Reality. These layers typically all have image textures built into the layer for lifelike rendering, but you can customize that inside the game engines because you have complete control over the rendering ultimately. So we'll discuss that in the advanced session later today. To provide geographic context, we support different types of base map, image tile base maps and vector tile base maps. And then there's 3D terrain, so the elevation or terrain that your content is draped over. What about data sources then? There are two patterns for working with geographic content with our Game Engine SDKs. You can either work with services, so connected to ArcGIS Online or ArcGIS Location Services or ArcGIS Enterprise, or you can also work with packages as well. So if you want your applications to run completely offline, you can use the same content types, all those layer types that I talked about, in packages running locally or accessed locally on the device. Or maybe a hybrid pattern. You might have an integrated mesh scene layer from a scene layer package, but you might be consuming a base map from a service. When working with the services, they can be either public, open services, or they can be private, secured services. So in terms of authentication, we support OAuth 2, but also API key for access to content as well. So OAuth 2 enables you to authenticate as a named user with ArcGIS or with your ArcGIS organization, and then access content that's been specifically shared with you. And then API keys enable you to access content from ArcGIS location platform services or your own private hosted data. What about geography and physics with the game engines? So to accurately place and render and interact with geographic data at a global scale or local scale with the desired level of spatial precision inside the game engines required some key innovations for both Unity and Unreal Engine. We typically refer to these as native geospatial placement, but essentially it means placing GIS data at its true geographic coordinates inside the game engine. So for Unity, this means working with their high precision framework, and for Unreal Engine, it means using version 5, which delivered support for double precision coordinates. We support a single spatial reference inside the game engine. So for global scenes or that round Earth experience, we support geographic coordinate systems. And then for that local scene or flat Earth experience, we support projected coordinate systems. The SDKs also include the ability for content that you add to the scene to participate as a mesh collider. So all of the layers in the map can participate as a mesh collider. This means you can more intuitively work with surfaces and detect interactions, leverage the physics of the game engine, for example, for raycasting to detect objects and elevation. And then the Maps SDKs also include a full geometry library as well. So there's a class called a geometry engine that provides you access to very fast, synchronous, fine-grained operations to compare and manipulate individual geometries. When you're a developer working with the SDK, you can develop on Mac OS or Windows, whether you're using our Maps SDK for Unity or for Unreal Engine. When it comes to deployment, we support deployment on Android, iOS, macOS, and Windows. So both Unity and Unreal Engine do also support Linux. We currently don't support deploying applications to Linux, but it is under consideration. So we're interested to hear from you if you're thinking about building applications that you want to deploy to the Linux operating system. And then you can deploy to a range of different hardware devices and device types. So high-end desktops, mobile devices, but also specific headsets and head-mounted devices that are built for augmented reality, mixed reality, and virtual reality. In terms of the developer experience then, in Unity, you're working with the C# API, or you're working with that low-code, no-code experience. And then in Unreal Engine, again, there's that low-code, no-code experience inside the IDE. They also have a visual designer system called Blueprints and a C++ API. So we integrate with any of those patterns. So you can use our Maps SDK in, for example, Unreal Engine, whether you're working with the UI, with Blueprints, or with the C++ API. And then for a better experience, and as you saw Zach showing in the demo there, at design time, when you're working in the IDE, we actually render that content at design time. So you can see the layers that you're adding, you can see the content, you can navigate around that. And then one important trend that we've seen in game engines themselves, and actually across the software development industry, is the increasing importance and enthusiasm for low-code, no-code experiences. So just as Zach showed in the demo earlier on, you can build up the scene, add a map, add a camera, set the origin and spatial reference. You can define the base map, add layers, elevation. You can set up your authentication, whether that's OAuth 2 or API key. And you can also take advantage of some of the new tools that we recently released in the latest release back in December to clip, mask, and replace content in 3D object and building scene layers or elevation and terrains as well. So that enables you to clip out areas and then overlay with other data sets. So what about what's new in the SDK then? So if you're already working with the Game Engine Maps SDKs, here's a quick summary of the enhancements that we've added over the last year. So we released version 1.2 in April, and that added support for building scene layers. So that was the first release that included that support for building scene layers. It enabled you to add and combine multiple elevation layers and then take advantage of the best elevation from that combination of elevation layers, but also a series of SDK enhancements as well. So new and improved samples, enhanced developer guide doc, and more integration in that low-code experience. With version 1.3, we added support for filtering of 3D object scene layers and support for modifications to terrain and integrated mesh layers, but specifically on desktops in that case. We added support for virtual tabletops with Unity and then additional SDK enhancements. And then in our most recent release in December, we really completed the support for building scene layer. So we added support for building scene layer attribute filtering. We added support on iOS, where I said in the previous release it was desktop only for their filtering and modifications. In our release in December, we added support for the filtering and modifications on mobile platforms as well, so Android and iOS. And then also the ability to replace elevation, so essentially flatten elevation to a specific value, and then the ability to replace that with other content. And then we matched our tabletop AR support that we released in the previous release in Unity with AR support and a sample in Unreal Engine as well. And then a glimpse of the roadmap. We're currently hard at work on our upcoming release, which will be 1.5 and scheduled for April. And in that release, we're primarily focusing on support for Esri's new global 3D object or 3D buildings layer, which is based on OpenStreetMap data. But beyond that, there's many capabilities that we're considering. Some of these may be higher priority than others. We're really interested to hear your feedback. Obviously, we have a good idea of what we plan to work on, and we're already laying the foundations and the groundwork for some of that. But if there's anything here that really interests you, then we really want to hear your feedback and help us prioritize and determine that roadmap. So in summary then, the Game Engine Maps SDKs are about bringing geospatial data to life in XR immersive experiences. They enable you to access ArcGIS data directly, so accessing packages and services. And then we include low-code, no-code experiences that we're building specifically to support you inside the Game Engine IDEs, Unity and Unreal Engine. And the way we think about our development is two parallel tracks. There is Game Engine integration, so those low-code, no-code tools that we're building inside the Game Engine IDEs, the ability to participate as mesh colliders inside the Game Engine. So you get a natural experience and you can take advantage of all the features you expect from a Game Engine. But then there's also ArcGIS integration as well, so adding support for additional data types like the building scene layer. And really, this is I suppose, a call to action, which is help shape the roadmap. So tell us what you need, tell us what you want to see in the SDKs. And then how do you get started? So Zach showed how you go to the ArcGIS developer site. You can download both the Unity, our SDK for Unity or SDK for Unreal Engine from the developer site. Zach also talked about how the SDK for Unity is available from the Unity Asset Store. That provides the most streamlined workflow to bring it into the Unity IDE. And then on the ArcGIS developer site, there's comprehensive guide documentation, so really good steps for installation, setup, and then a tutorial about just simply getting started and displaying your first map inside the Game Engine. And then a series of developer code samples for showcasing different aspects of working with ArcGIS and working with the SDK. But there's also the Esri Community, so that's a great place to reach out to other users, so peers in your community, but then also people on the team at Esri as well. And then because the game engines are relatively new technology from the perspective of Esri, at least in terms of our support for developing with game engines. And I think that's probably reflected in many of the organizations and users that use our software. You may not necessarily have the skills to build applications with game engines. So you can get project assistance from Esri Professional Services. We've got many engineers in professional services that have been doing some really great work with the game engines on a number of projects already. And then we also have a number of partners that have expertise building applications with game engines as well. If you enjoyed the session today, or if you have any feedback, please share that through the app. We always want to hear feedback and help us improve these sessions so we really give you what you need. Connect with us on social. And then now we've got time to take some questions. So hopefully people that joined online have been asking some questions. Otherwise, we're free to take questions in the room. Any questions online? Wow, okay. Okay, people online are pretty quiet, no questions, but let's take some in the room.
Yeah, I was wondering if you could compare and contrast the two different game engines. Are there strengths and weaknesses?
Mm-hmm. So the question is, can we compare and contrast the different game engines, Unity and Unreal Engine? Are there strengths and weaknesses? From our perspective, in terms of the support that we provide in the game engines, we try to be agnostic. We want you to have the ability to choose based on your experience and your skills. I suppose so I talked about the languages that you use when you're developing with Unity and Unreal Engine. So Unity, C#. So if people have .NET, C# experience, we see them leaning towards Unity. If people have C++ experience, we tend to see them leaning towards Unreal Engine. Maybe often people that are using our game engine SDKs actually really have some experience, or they have somebody on the team that was the game engine guy at some point, guy or girl, and they have some experience, and that might play to Unity or Unreal Engine. So it really depends. Maybe also there's the availability of particular plugins or assets that are coming from other vendors. So maybe you've seen something in the Unity asset store that you like the look of that you want to use, then that's going to make you head more towards Unity. But yeah, there's also the Unreal Engine marketplace as well, and there are many assets there. So those kind of things. Zach or Mason, any thoughts about whether you choose, that might guide you to choose one over the other?
Unreal Engine does have the blueprint system, which is, you do still need to have a fundamental knowledge of how to code, but it does eliminate the actual script writing aspect of coding. Additionally, both engines do have their pros and cons. So Unreal Engine is generally better at offering more higher fidelity, better looking graphics, but it's also much more taxing to run. Unity is much better for virtual reality, mixed reality, augmented reality experiences. So if you're planning on building a virtual reality application, I'd point you in the direction of Unity just because they have much better support for getting started with XR, anything.
Yep.
It really does come down to personal preference, though. I'm more of an Unreal Engine guy, and I think Zach's more of a Unity guy, and we go back and forth on it all the time.
Yeah.
Not physically back and forth, though.
No.
It doesn't get too rough. Okay. Any other questions?
We have one in the online.
Oh, okay. Great. We'll just take a question online.
Is it possible to extrude a 3D model from a 2D feature using attributes? The attributes have elevation and feature height values.
Okay. So the question's about extruding features that you're bringing into the game engine based on attribute values in there, so attribute values that represent the height. Yeah, you could totally do that. We see, I suppose that there are different workflows for that. Sometimes you might do that in ArcGIS Pro, for example, so bring in building footprints, extrude those, maybe publish that as a 3D object scene layer. But you could also do that in the game engine itself as well. Currently, we don't have direct support for feature layers in the game engine, but we do have examples of how you make queries to feature services to retrieve geometry and attributes So you can then represent that geometry and attributes inside the game engine, and then you could extrude that based on attribute values that you've retrieved from the service. So there's a few different workflows for achieving that. All right, I think there was a question at the back there.
Yeah, currently in our development, we're using CPU for large-scale integrated mesh around the class area. Is there discussion of Esri creating that kind of large-scale 3D integrated mesh base map that we can go ahead and bring in the project?
So yeah, the question was, you're currently using another plugin that provides a wide-scale integrated mesh data set, maybe 3D tiles possibly. And is Esri planning to provide an equivalent wide-scale or global-scale data set as an integrated mesh? I think long-term we'll see that happen. We recently released 3D base maps that are gradually rolling out across ArcGIS. So the idea of 3D base maps, you can see that in ArcGIS Pro. You can see that appearing in the scene viewer. So support through the JavaScript API into the scene layer. Our native maps SDKs added support for those 3D base maps or some of the layers, so a subset of the layers there. And then in the game engine SDKs, we're currently working on support for the building layer there. So it's a 3D object. So discrete 3D objects that represent buildings, but at a global scale. Those 3D base maps contain essentially a 2D base map, the OpenStreetMap 2D base map, then elevation, and then buildings. There's also other content in there as well, so points of interest with 3D labels. And ultimately, we'll see those 3D base maps come to life. They currently don't contain a kind of wide-scale integrated mesh, but we're in conversation with partners about acquiring that data and building up that wider-scale integrated mesh. So I think over time, we'll see that. We're also across a range of ArcGIS products adding support for 3D tiles, so the ability to bring in 3D tile integrated mesh content directly into ArcGIS software. And we've seen that in ArcGIS Pro. We're adding support in our native maps SDKs, and then it's on our roadmap for the game engine SDKs as well. So whether you're working with integrated mesh that follows the I3S, the OGC or I3S specification, or the OGC 3D tile specification, we'll be able to bring that into the SDKs ultimately. All right, any more of mine? Okay, any more questions in the room? All right. Okay, if there aren't any more questions, then thank you very much for joining us for this session. Please chat to us afterwards, find us on the showcase, engage with us in the Esri community.